All right, Algebra 1, here we go. Another video. Now we're starting with the second part 2 of chapter 8. So we're looking at 822 today. I figured I'd better go over the bell ringer as well in these videos, so that way you can see how you did on these. Sorry I'm not back yet. It's going to be another week. Okay, I should for sure be back by next week. Okay, so please keep working hard. Please keep treating the sub nice. And it'll be worth it. Okay, so 822 bell ringer, here we go. Just factoring, so a review from last week factoring. These first ones, or all 4 of these are actually, you got to focus on factoring completely. So each one of these you have to factor out a GCF first. So looking at those numbers, the biggest number we can divide out is a 2. So factor out that 2. And then always check this one here. We can do the shortcut. So you can just make your diamond off to the side. 2 numbers that multiply to 10 that add to negative 11. And that's going to be negative 1 and negative 10. So those are my 2 factors. Don't forget to write the 2 out front. Otherwise this would be incorrect. So make sure you are writing that 2 out front for factoring completely. Okay. Same thing on this second one here. You had to factor out a 3 first, and then 2 numbers that multiplied to 8 that added to negative 6 were negative 2 and negative 4. So there's your factors on that one. Okay, so double check your answers there. Pause if you need to copy that down. Okay, and then here's the last 2. So this one here, this was a tough one. Okay, you had to factor out a 2. That was the greatest common factor, the GCF. And then you have this messy factoring problem, so you have to multiply. You got to make your box, make your diamond, and the 2 numbers are 4x and 49x. That multiply to 196 and add up to 53x. So those are your 2 numbers that go in your box. Okay, and then factoring here. Okay, this is what you should get for your final answer. Don't forget the 2 is out front that we factored out from the beginning. Okay, so double check that one. And finally, check this one as well. Pause if you need to. Okay, just double check. Make sure you guys did well on the bell ringers. Okay. All right. Okay, moving on. Hopefully, at this point, make sure to hand out the 822 notes or the entire part 2 packets for chapter 8. Make sure those all handed out. And you're going to need your books. Well, let's actually look. Actually, you can probably do it without your books. So you don't need your books open. We can probably just go through here without. Okay, you can just follow along with me. So we are starting to look at the whole point of quadratics is parabolas. That's kind of the whole point, is it's what it looks like on a graph. So to go over this, we are going to first look at what is a parabola. Okay, so let's just look at the very parent function of a parabola, where it's just y equals x squared. So let's graph it. So when we graph it, we always want to make a t-chart, and let's just pick some numbers that we want to plug in. So let's plug in the first, the basic numbers, the numbers that surround 0. So negative 2, negative 1, 0, 1, and 2. And now if you think about plugging each of these numbers in, I think we did this on a homework assignment a while back. If you plug in negative 2 squared is 4. So that's one of our points. So let's go to our graph and let's plot that point, negative 2 and 4. Okay, so we go negative 2 on the x, 4 on the y. Okay, then if we do negative 1 squared, if we plug that in here, negative 1 squared is positive 1. So we're going to get a 1. So when we're at negative 1, we're going to be up 1. Okay, and then 0 squared is 0. 1 squared is 1. 2 squared is 4. Okay, so we have the point 0, 0. So if we plot that, that's the origin. Then we have the point 1, 1. So over 1, up 1. And then we have the point 2, 4. So over 2, up 4. Okay, so hopefully you're kind of seeing a pattern here. Our pattern is that whatever our x value is, we're just squaring it to get the y value. So, for example, if we did 3, we know that would give us 9. So you could count up to 9 here. So there's 9. And then it has this symmetry effect, where whatever is plotted on one side, it's exactly the same on the other side. So at -3, that's also going to be at 9. Okay? And then, okay, perfect. So then if we went to 4, that would be at 16, and that's going to be clear up at the top of your graph here. So it has that sort of U shape that's going on here. And we can trace the line going through here. So go ahead and trace that line. Okay, try your best. All right, so there's our U shape. Okay, so let's write that down for our pattern here. Okay, it's a U-shaped graph. Let's see. You want to write that there? Yeah, we can do that. So U shape. Okay, so it's got a U shape. And it follows this pattern. So here's our pattern that we're going to say. This is what I learned back when I was in high school, is that a parabola from the vertex, let's label that, this point at the bottom where it turns, this is called the vertex. Okay, so that's a turning point. So from the vertex, all parabolas do this, or at least in Algebra 1, the ones that you're going to study do this. They go over 1, up 1 on both sides. Over 2, up 4. Over 3, up 9. That's sort of the pattern that they follow. So let's write that down. So from the vertex, on both sides, let's just write it. So they go over 1, up 1. Okay, then they go over 2, up 4. Over 3, up 9. That's the pattern that they follow on both sides. So let's make a little note here that this is happening on both sides. Okay. All right, what else? What else can we write? It has a, so what we mentioned here a little bit was a line of symmetry. So I want you guys to draw a little dotted line. You might have to kind of make it darker or use a different color. I'm just going to use a dotted line going off to the side. In this case, it's our y-axis. That's the line of symmetry. And what that means is we could fold this in half, and it's the same on both sides. So that's our line of symmetry. Sometimes we'll abbreviate that as LOS for line of symmetry. Okay. All right, so our goal by the end of the day is to be able to graph this from an equation. Okay, so let's take a look at number 64, and I'm going to have you guys pause it here in a moment. So it's asking us here, what do we need to sketch a parabola? So once we have an equation, we want to find the least amount of information that we need in order to have a complete sketch of the parabola. Okay, so if we look at letter A, it says, can you sketch one specific parabola if you only know where its y-intercept is? For example, the point 0, -15. So let's just plot that point on our graph below here. So let's just say this is the point 0, -15. We're just gonna estimate that that's that point, okay, down there. It's asking you, can you sketch a parabola, only one unique parabola that goes through the point 0, -15, or are there multiple that go through that point? Okay. Then it moves on to letter B, and it says, what about two x-intercepts of the parabola? So for example, if we had the point -30 and the point 50. So let's go ahead and plot that. So -30 and 50. So let's say we knew both of the x-intercepts. Is that enough information to draw one unique parabola, or do we need more information? Okay, I want you guys to pause the video here and answer these two questions. Okay, go ahead. All right, hopefully you guys pause the video. If we look at letter A, this is not enough information. You can draw a bunch of different parabolas that go through here, so no. Okay, this is not enough info. Okay, we need more. Because a lot of you are maybe thinking, well, yeah, we can draw a parabola that looks like this. okay, which is true. But you could also draw a parabola that maybe does something like this. Goes through that point and does something like that. So there's two different parabolas that I've just drawn that go through that same point. So this does not work. You could also draw a downward facing parabola going through that point. There's a lot of different things, okay? So if you only know the y-intercept, that's not enough information. Okay, now what if we have the two x-intercepts? Well, we know we have to have our line of symmetry. So right in the middle of these 2 points, we could get that line of symmetry. We could find that middle. Okay, it'd be around there somewhere. And then we know that our parabola has to either do something like this. Okay, but this isn't the only parabola that goes through those 2 points. Some of you may have thought of the parabola that goes upside down. Okay, so again, even having the two x-intercepts is not enough information to draw our parabola because you can get two different parabolas. Okay, so we need more information. So this is not enough information. We need more. Okay. All right, let's flip it over to the next page. All right, if we look at this page, it says, now can you sketch a parabola with only its x-intercepts and y-intercept? For example, if we had the points from the previous page, -3, 0, 5, 0, and 0, -15. So let's plot those points. So we have the point 0, -15. Then we have the point, and let's try to kind of get this to scale here. This would be around -3, 0, and then 5, 0. Okay, somewhere around here. Okay, we're just sketching this. It doesn't have to be perfect. Okay, if we had those 3 points, is that enough information to determine the parabola? And the answer for this one is yes. Yes, this is enough information because we know where our line of symmetry is. Okay, it's going to be somewhere around here, so you can draw a dotted line for your line of symmetry, meaning the parabola has to fold in half, and it has to be in the same spot on these 2 points. Okay, and our only option is either to do an upside down parabola or upward facing parabola. So it's either downward facing or it's upward facing. And in this case, since we now know this point, now we can know that it has to be upward facing, because you can't have a downward facing parabola that goes through this point. It wouldn't do something like this. Okay, that's not a parabola. It has to be a perfect U shape, either upwards or downwards. So we can draw an accurate sketch going through here. That's going to do something like this, and it's going to turn right at the line of symmetry, and then it's going to go up. Okay, so having those 3 points is enough information to draw our parabola. So this one, we are going to say yes on this one. That is enough info. Okay. All right. Okay. And then part D in the book, if we take a look at that, it was asking, where is the line of symmetry? So we can get our line of symmetry from the x-intercepts. Okay. So the line of symmetry, we want to say it's the exact middle of our x-intercepts. So let's write that down. So it is the middle of the x-intercepts. Okay, middle of the x-intercepts. That's going to be our line of symmetry. Okay, so how do we find the middle of 2 numbers? Well, there's multiple ways you could do it. You could just count and think, okay, going from -3 to +5, if I were to count on a number line, that's 8 away, right? And what's half of 8? Well, that would be 4. Okay, so if you're 4 away, you could count, either 4 less than 5 or 4 more than -3, and then that line of symmetry would be right in the middle at x equals 1. That would be halfway between these two. Okay, that's one way to do it. Another way, what I like to do is just find the average. Okay, so average of x-ints, just abbreviate there, average of your x-intercepts. So if you take -3, 0, and 5, 0, if I want to know the exact middle of those 2 points, I'm going to find the middle of -3 and 5. So to find the average of 2 numbers, you add them together, and then you divide them by 2. So negative 3 plus 5, that's going to give us 2 divided by 2, and 2 divided by 2 is 1. And that's how we find the middle. So this is what I like to do, but if you'd rather count, you can probably count and find the middle of your x-intercepts that way. Okay, and this is a huge thing because once you find your line of symmetry, you can easily tell whether it's going up or down, your parabola. Okay, so the line of symmetry, or the LOS, is at x equals 1. Okay, there you go. So anytime you're graphing your parabola, you want to find the middle of your x-intercepts. That's your line of symmetry. So let's do an example. Okay, it says review over x-intercepts and y-intercepts, and we're going to graph this quadratic right here. It looks daunting, but we're going to break it down step by step. Okay, the first thing you guys want to do when you're graphing a quadratic is you want to find your y-intercepts and you want to find your x-intercepts. Okay, sorry, that should say y-intercept. Get rid of the s there, and this should say x-intercepts with an s there. Sorry about that, a little typo there. So there's only one y-intercept ever, and there's almost always two x-intercepts. Sometimes there's only one, sometimes there's actually none. Okay, so to find your y-intercept, I want you guys to write this in parentheses. That is where x equals 0. Because if you think about your y-intercept, like on this problem up here, our x value, here's our x value, here's our y value. Your x value is always going to be 0 on the y-axis, which is where your y-intercept would be. Okay, and then your x-intercepts, that's where y is going to equal 0. Okay, if we think about our x-intercepts here, it goes x and then y, x and then y. Notice on our x-axis, our y value is always going to be 0. Okay, that's really important because that's going to help us down here. So for this one, if I want to find my y-intercept, I'm going to plug in 0 for x in my equation. Okay, so let's do that. So we've got y equals 2x squared plus 5x minus 12. And any time here where I see an x, I'm going to plug in 0. Make sure you guys are writing this down. Make sure you're writing down everything that I'm writing down here. Okay. So if I plug in 0, let's do that. We got 2 times 0 squared. I'm going to plug it in with parentheses. Plus 5 times 0, and then minus 12. Well, if we plug this in, 0 squared is 0, times 2 is 0. That all just cancels out. And then 5 times 0, that's just 0. That cancels out. All that we're left with is a negative 12. So we get y equals negative 12. Okay, this is huge because this is our y-intercept. That's a point. So let's put that point, let's write that down. So at 0, negative 12, that is our y-intercept. Okay, huge. Awesome that we found that. So that's how easy it is to find your y-intercept. And if you look at that, it was this number right here because these two terms canceled out and we're left with that negative 12. That's your y-intercept. Okay. All right. Next, let's do our x-intercepts. Now this one, our x-intercepts is where y equals 0. So let's plug in 0 for y in our equation up here. So we're going to say 0 equals 2x squared plus 5x minus 12. All right, so now that we have this equation, we have to solve this quadratic equation, okay? And in order to solve this, we actually have to factor it, okay? So let's go ahead and factor that, and let's just see what ends up happening. So let's get our product here. So let's make a box and diamond. I want you guys to go ahead and factor this off to the side here. Make your box, make your diamond, and go ahead and factor this quadratic and get your product down here. So pause the video, factor that, take like a minute and a half, okay? Time it, go. All right, guys, so hopefully you pause the video here. I'm gonna run through this really quick. So if we have 2x squared here, negative 12 here, putting those numbers in, and then in our diamond, we have 5x on the bottom, and then negative 24x squared on the top when you multiply these two, okay? So now I'm looking, you can look on your factor chart, look for two numbers that multiply to 24, and then have a difference of 5. And those two numbers are going to be 8 and 3. And we want to make the 3 negative to give us a negative 24 and add up to a positive 5. So my two numbers are negative 3x and 8x that go in my box. And then you want to solve your box, and you should end up getting these numbers. So you should have 2x minus 3 and x plus 4. Okay, again, you guys should know how to do this from last chapter. Make sure you keep practicing factoring if you're still struggling with it a little bit. All right, so now we need to solve this. Now this is where it gets a little bit tricky. We have two things that are multiplied together that equal 0. This is where we have to talk about what's called the zero product property. Okay, so I want you guys to write this down, a little equation here. We have A times B equals 0. Okay, pause the video for a minute and talk about with your teammates what you know about these two numbers. We don't know what they are, but let's say we have A and B, two numbers, and they multiply to equal 0. Talk about with your teammates for 1 minute. What does that mean? Go. All right, so hopefully you guys talked about it with your teammates and you found out that one of these numbers has to be 0, or both of them are 0. So either A is 0 or B is 0. Those are your two options. One of these has to be true. So now what I'm going to do is I'm going to take that back to this problem over here. We have the same thing going on. We have two things that are multiplied together that equals 0. And in order for that to be true, one of these expressions has to equal 0. And that's going to be our solution. So what we're going to do is we're going to set these equal to 0. Okay, so we're going to have 2x minus 3 equals 0. And then we're going to have x plus 4 equals 0. And now we're going to solve these. Because in order for this statement to be true, one of these, like I said, has to be equal to 0. So take a second, pause and solve these. Should take you around 30 seconds to solve these two equations. They should be super easy. Okay, pause and go. All right, so your solutions to these, you have to add 3 to both sides of this equation. You get 2x equals 3, and then divide by 2, and you get x equals, you could write it as 1.5, or I like to just leave it as a fraction. Well, on this one, I'll write it as a decimal, so 1.5, okay? And then this one here, super easy. You just subtract 4, and x equals negative 4. Make sure it's a negative. Okay, so there are your two x-intercepts. Okay, so let's write those down. So you have the point negative 4, 0, and the point 1.5, 0. All right, let's write that as x-intercepts. All right, so now let's zoom out a little bit here. So now we have our y-intercept and we have our two x-intercepts. Now we can sketch an accurate graph of this. So let's go ahead and do that on this graph below here. And we're just going to sketch. So let's put negative 12 down here. That's our y-intercept. That's from this number right here. And then let's just estimate where these are going to be. So we're at negative 4. So that's going to be around here somewhere. And then 1.5, that's going to be around here somewhere. So this is at negative 4, 0, and 1.5, 0. We're just sketching. This isn't going to be super accurate. Okay, I'm going to zoom in a little bit more here. All right, now we can draw an accurate sketch. So first of all, think about where your line of symmetry would be, somewhere in the middle of these two. If you wanted to be super accurate, you could actually type this in your calculator and find the exact middle, the line of symmetry. And it's going to be around like negative 1 point something. So somewhere around here. So my drawing's not super accurate, but you can kind of get the point. So let's draw a line of symmetry. So now we should be able to fold our parabola in half based on that line of symmetry. So our parabola is going to look something like that. Okay, and it's just a sketch, doesn't have to be perfect. All right. Okay, so pause the video here. Talk to each other if you have any questions. Okay, the main thing is we just used our x-intercepts and our y-intercepts to sketch this parabola. Once you have those 3 points, you can easily sketch your parabola. All right, let's practice. Move on to the next page. And I want you guys to practice this one here. So let me get you started. So first thing, always write off to the side here, you want to write your y-intercept. And that's where x equals 0. This is what I want you guys to write on every single problem that you're graphing, every single quadratic that you're graphing. Y-intercept is where x equals 0. And your x-intercepts, x-intercepts, sorry, bad handwriting here. X-intercepts is where y equals 0. Okay. Sorry, it's hard to write with the camera right there. Okay, so we got our x-intercepts is where y equals 0. Y-intercept is where x equals 0. All right, pause the video here. You're going to do the exact same steps that we did on the previous problem. Okay, pause and try to get that done. All right, here we go. So on this one, let's find our y-intercept first. That's the easy part. We just plug in 0 for every x that we see up here. So I'm going to say y equals 0 squared minus 2 times 0 minus 8. Okay, well 0 squared cancels out, negative 2 times 0 cancels out, and we're just left with negative 8. You'll notice that happens quite a bit, that this last number is your y-intercept. Okay, so now I know my y-intercept is at 0, comma, negative 8. That's one of my points. Okay, there's my y-intercept. Now I need to find my x-intercepts. So that's where y equals 0. So let's plug that in. So 0 equals, so I plug that in for y. 0 equals all of this. So we have x squared minus 2x minus 8. And now we need to factor this. So we can factor and we can just make our diamond. So let's make our diamond here. And let's see. If we factor this, we need two numbers that multiply to negative 8 and add to negative 2. And that's going to be negative 4 and positive 2. So my two factors are x minus 4 and x plus 2. All right, so now at this step, this is the zero product property. This is where we need to set both of these equal to 0. So we need to say x minus 4 equals 0 and x plus 2 equals 0. Because again, these are two things that are multiplied together that equal 0. In order for that to be true, one or both of these have to be equal to 0. Okay? So if we solve this, you add 4 to both sides, and you get x equals 4. Okay, there's one x-intercept. And then this one, you subtract 2 from both sides, you get x equals negative 2. Okay, so our 2 points are 4, 0, and negative 2, 0. There you go. So now we have our y-intercept and our two x-intercepts. Now we can graph our parabola. Now, one extra thing here, it wants us to find the vertex on this problem. So if you want to find the vertex, that's going to lie somewhere on the line of symmetry, right? Because if we look at our parabola here, the vertex is that turning point, and that is on your line of symmetry. So let's find that line of symmetry. So again, we have to find the middle of our x-intercepts. So let's do that up here somewhere. So let's say line of symmetry. So if I want to find the middle of 4 and negative 2, you can probably just count it out or just add them together. So 4 minus 2, we're going to average these. 4 minus 2 divided by 2 is 1. Okay, 4 minus 2 is 2, 2 divided by 2 is 1. So that's our line of symmetry. So that means our vertex is going to be where x equals 1. Okay, so if I plugged 1 back in to this equation, I could find my y value. So let's go ahead and do that. So y equals, I'm going to plug 1 in every time I see an x in this equation. So y equals 1 squared minus 2 times 1 minus 8. Okay, and if you solve this, 1 squared is 1, minus 2 times 1 is just minus 2, and then minus 8. 1 minus 2 is negative 1. Negative 1 minus 8 is negative 9. So that means my vertex is going to be at 1, negative 9. So let's put that in our vertex spot here. Sorry, positive 1. Should be a positive 1 there. So positive 1 and negative 9 is where our vertex is. All right, let's plot these 4 points and let's get that sketch of the graph. So let's count down here to negative 8. So there's our y-intercept at 0, negative 8. So that's this point right here. And then our vertex is over 1, and it's at negative 9. So let's put our vertex around right here. And that's where our line of symmetry is going to be. So we could draw our line of symmetry. I like to draw a little dotted line there. You don't have to draw that in, but it's nice to see it. And then at 4, 0, and then at negative 2, 0 are our two x-intercepts. So now you can draw a very accurate sketch of your parabola with those 4 points. So we've got those 4 points. There is our parabola. That's what it should look like. Okay, so we've got the point negative, positive 1, negative 9. We've got the point 0, negative 8, 4, 0, and negative 2, 0. And there you go. Okay, last one. I'm going to make this one super quick. Go ahead and pause the video here. Practice sketching this one. I want to wrap up the video here, so I'm just going to run through this one really quick. Okay, so pause the video, try sketching that, and then we'll run through it. All right, so this one, our y-intercept, when you plugged in 0, you should have gotten y equals 3. And so our point is at 0, 3 for our y-intercept. And then our x-intercepts, when you plug in 0 and factor this, let's just do that really quick. If we factor it, let's make a box, make a diamond, so let's see, we got 1x and 6x. So I'm just flying through this one. Just pause it if you need to. Oops, that doesn't need an x. Okay, so when we factor it, we should have 0 equals 2x plus 1 and x plus 3. So if you set these equal to 0 and solve them, you get x equals negative 1/2 and x equals negative 3. Those are our two points. Okay, and then it wants you to find the vertex on this one. It would be halfway between these two. So if you found the midpoint of negative 3 and negative 1/2, it's at negative 1.75 for x. Yeah, and that's not going to be a nice number. And then you have to plug that back into here and see what that is, which is not going to be a nice number. And I believe, if I didn't make a mistake here, it's at negative 3.125. Okay, gross. Okay, main thing is that you guys know how to find the x and y intercepts on this one. So there's our x-intercepts, there's our y-intercept. So if we plot our points here, we've got the point at 3. So let's go 1, 2, 3. There's our y-intercept from this number right over here. And then our two x-intercepts are at negative 1/2 and negative 3. Okay, and our vertex is at negative 1.75 and negative 3.125, so somewhere down here. Okay, there you go. All right, guys, so this was a long video, so thank you guys for being patient. Thank you for working hard today. keep working hard. We'll practice more of this in the future. This last one was kind of a tough problem, okay? If you need to go back and rewatch, this is on YouTube, so you can always watch and get some more practice, okay? All right.